This is what I do with the free fall tube to demonstrate free fall in a vacuum. Notice that I'm actually plugging the big motor up to the wall socket over there in the interest of not plugging it into the same thing as the computer. Okay. The first thing I do is I demonstrate the feather. Demonstrate the feather. There it is. I demonstrate the feather, right? It's like feather, not in a vacuum, right? Feather has a terminal velocity of 10 centimeters a second or something like that, right? Then there's the ping pong ball, right? Well, the ping pong ball seems to fall freely, right? But I'm pretty sure its terminal velocity is somewhere like 30 miles an hour or something like that, right? I mean, you can, right? I don't know how fast that is, right? But it's, it's not 100 miles an hour. I think we can all agree, right? Okay. And then of course there's also there's also the steel marble. Well, I'd hazard a guess how fast this has to go before the air friction keeps it from accelerating, right? I never put the steel marble in that because it's not really going to show anything, right? And then of course, the next thing is, of course, we want to see the feather in a vacuum. Okay, so I kind of Nicolas Cage it because I once had the feather stick to the side. Okay, so on this side, I've got just a rubber cap. It's a sewer cap there, and sometimes it needs vacuum grease. But the problem with vacuum grease is if it gets on the feather sticks. Right, and then this thing, pop on there. Make sure this valve is open on this end. Okay. And then you can turn it on. Now there's a little petcock that's closest to this metal thing. There's a little petcock, not the big one, but the little one. I open that up first. And then, while it's coming up to a vacuum, and this one really wants a vacuum, okay? While it's coming up to vacuum, this is a perfect time to talk about the difference between suction and what's really going on, right? And what's really going on is that the atmosphere is pressing in on that, right? It's 15 pounds for every square inch or something, right? It's a lot of force. And then once it starts making a little boy sound, screw that last thing in, and you'll loosen. And wait till it does the bory sound really slowly. And you have to have your sign ready. Okay. That's pretty good. I think it's pretty good, right? So what I'm going to do is I'm going to turn this there's a valve on this. I'm going to turn it right angles to the pipe to block it off. Turn this off. Take that off, right? And then it's like, you ever see a feather go clunk? And then you got to hold up the applause sign, right? So I don't know if you can see that. Hopefully you can. It's just the feather just goes clunk, right? Boom. Boom. More applause, right? And then you let the air in. You have them predict what's going to happen when I let the air in. You get the end of Forrest Gump, right? It's like the feather goes all the way up there. All right. So then the question is, how much? I always have them clap for the feather when it goes back in its little thing. Then the question is, how much does the air affect the ping pong ball? It seems like the ping pong ball is moving pretty well in here, right? And I do this for a little bit, right? I mean, it's moving, but I do have to move my hand a little bit to get it going, right? So then, and of course, the answer is that it's going to affect the ping pong ball more than it would in the open air because you've sort of got that tunnel effect, right? Going on. Again, loosen the little thing, turn this on. And then, one time I had the ping pong ball just stick to this end. All right. The ping pong ball isn't as picky about its vacuum. This is a good time to tell a joke, you know? All right. There we go. And now I'm going to do the same thing. I'm going to turn this valve 90 degrees, turn this off, unplug it, right? And then the question is it moving easier? Oh yeah, I mean, it's just rocketing from the end of the tube to the other side of the tube. Imagine real ping pong, right? Between real ping pong players, like really good ones, right? In a vacuum. Assuming the players didn't have to wear, right? So, and you could talk about, what is it, the hyperlink or the hyper or whatever, the thing Elon Musk proposed of the evacuated tunnel. You can talk about, this is why airplanes fly so high, because the air's thinner, less air. Right? The air gets in the way. You could talk about the, how there are tunnels to relieve the pressure in the channel, right? In the, because where the trains go through, right? The air piles up in front of the trains. And then have them predict what the ping pong ball is going to do when you let the pressure in. What's it going to do? Science cannot explain everything, unless the inrushing air, due to the Bernoulli principle, represents low pressure. The ball moving toward the middle reduces its moment of inertia. Any residual angular momentum it has, the velocity increases to compensate for the lack of moment of inertia. It could be that. I don't know. They can clap for the ping pong ball too. Anyway, that's what I do. I don't really spend a lot of time. I mean, the kids are, you can also, if you want to develop an idea about terminal velocity, you can talk about the vertical wind tunnel, like iFly, right, or whatever that is. And they do a really good job. I'm not sure I'd do a field trip to them, but it's kind of fun, especially if you're limber. They do a shtick where they put different size objects in the vertical wind tunnel, and you can see what velocity, what's the terminal velocity of all these different objects, right? Yeah.